All right, this is section 2.4, video 2. We've figured out how to take the derivatives of the 6 trig functions. So this is just a little bit more practice, and then the proof for sine of x being the derivative of sine of x at the end. All right, so let's go ahead and do a few of these problems. So if I want to take the derivative of y, which is sine of x minus cosine of x, y prime is going to be the derivative of sine, which is cosine, minus the derivative of cosine, which is negative sine. So cleaning that up, you just get cosine of x plus sine of x. And that's it. In number 7, y prime is going to be the derivative. This is a quotient rule, the derivative of tangent. So the derivative of the top is secant squared x times the bottom, x plus 1, minus the derivative of the bottom, which is 1, times the numerator, tangent x, all over x plus 1 squared. Okay, pretty much the only thing you could do is distribute the secant squared. In this case, there's really no reason. I think that's pretty clean. Okay, and number 8, we want to take the derivative of y equals sine of pi fourths. Be careful, pi is not a variable. Sine of pi fourths is actually just the square root of 2 over 2. If I want to take the derivative of the square root of 2 over 2, that is a constant. So y prime is 0. Be careful on that. Again, when you see pi or e, those are not variables, they are numbers. Okay, number 9, y equals x cubed sine of x. So once again, product rule, the derivative of the first, 3x squared, times the second, sine of x, plus the derivative of the second, cosine of x, times the first. I'm going to just go ahead and put this right out in the front so it is already cleaned up. We're good to go. That's it. In number 10, so I've got, first of all, the derivative of x squared, which is not attached really to the 2x cosine of x. It's just being added. So we're going to do those as separate pieces. So y prime will be the derivative of x squared, which is 2x plus. Now I have to perform the product rule. 2x cosine of x is a product. So the derivative of 2x is 2 times the second, cosine of x, plus the derivative of cosine of x, negative sine of x, times the first, 2x. Only thing I'm going to do now is, like I said, I am just going to clean this up a little bit by moving that negative sign out to the front of the 2x. And yes, you could factor out a 2, but again, no reason to do so right now. All right, number 11, y equals x divided by secant x plus 1, quotient rule. Derivative of the top is 1 times the bottom, minus the derivative of the bottom. The derivative of secant x is secant x tangent x, or tangent x secant x. Derivative of 1 is 0, so then times the numerator, which is x, all divided by secant x plus 1 quantity squared. And again, just to save a little time, the only thing you really could do to clean this up, you don't need the 1 out in the front of the first term on top, and you can move that to the front of there. Other than that, nothing really else to do. And then the last one on this page is another quotient. The derivative of the numerator is 1 times the denominator, minus the derivative of cotangent is negative cosecant squared x times the numerator, x, all over cotangent squared x. I'll just go ahead and clean this one up real quick. That's going to be cotangent x minus x cosecant squared of x divided by cotangent squared of x. There you go. So that's just a little bit more practice, incorporating not only the trig, but our power, product, and quotient rules. Those are the 4 rules that we know so far. All right, and as I promised, oh, I'm sorry, we forgot we had a couple other things to do here. No problem, we're still going to finish it up. It will still be a relatively short video. So we want to find where the graph of f of x equals the square root of 3 sine x plus 3 cosine x has a horizontal tangent. To have a horizontal tangent, that means that the slope has to be 0. And since we are talking about the slope of a function, we know we need to take the derivative. Slope is the derivative of the function. So the first thing I need to do is take the derivative. The derivative of square root of 3 sine x. Square root of 3 is just a constant coefficient, so it can be pulled out. So it's really just going to be the square root of 3 cosine x. The derivative of 3 cosine of x is going to be negative sine of x times 3. So that's negative 3 sine of x. And I want that derivative to equal 0 because I want it to be horizontal tangent. So now what I need to do is I need to solve this thing for x. It's going to be kind of challenging having it in these two variables, so we need to try and get it down to 1. And when I say variable, I mean the fact that it's two different trig functions. I need to try and get it down to 1. If one of the two of those was squared, I could change them all into terms of one or the other. They're not squared. We're not going to just square both of them because that actually changes the function. So what we're going to do is we're going to add 3 sine x to both sides. Then I'm going to divide both sides by 3. And then we're going to divide both sides by cosine of x. And if I divide sine of x by cosine of x, that gives us tangent of x. So now we have to know our unit circle values pretty well. Tangent of x, to find these values we're talking about, and we're just going to do one circle in this case just to make it a little bit easier. Our tangent values here are going to be when x is at pi 6 or when x is at 7 pi 6, because tangent will be positive first and third quadrant, and those are the locations where tangent is going to be square root of 3 over 3. Okay, and if you haven't memorize those, or if you haven't come up with a quick way, you will definitely need to make sure you do that. If we were going to do this for an infinite number of them, we know we would have to add this 2 pi n to both of them. But the first two answers are basically one circle. All right. Last problem before we get into the proof. Find the equation of the tangent line to the curve y equals secant x minus 2 cosine x. Should say at the point pi thirds 1. To find the equation of a tangent line, we need 3 things. We need the slope, we need the x, and we need the y. Well, they gave us the x and the y. We just need to find the slope, so we need a derivative. So y prime, the derivative of secant x is secant x tangent x minus the derivative of 2 cosine of x is going to be negative 2 sine of x, so the minus minus becomes a plus 2 sine of x. Once again, we want to find the equation of the tangent line to the curve at that specific point. So I need to find the slope at the x value of pi thirds. So that's going to be secant of pi thirds tangent of pi thirds plus 2 times the sine of pi thirds. This is just to find the slope. So let's see, secant of pi thirds. I don't really remember secant of pi thirds off the top of my head, but what I do know is the cosine of pi thirds, which is a half. But since secant is the reciprocal of that, I'm going to flip 1/2 over, and I know that secant of pi thirds is 2. Okay, tangent of pi thirds. I know that tangent is the same as sine over cosine. I know that sine of pi thirds is square root of 3 over 2. I know that cosine is a half. So if I was going to do square root of 3 over 2 over 1/2, when you divide those fractions, technically the 2's are going to cancel themselves out, and you get the square root of 3 over 1, or just the square root of 3. And then 2 times, again, sine of pi thirds is square root of 3 over 2. Okay, in this case, these 2's are going to cancel out. So really what that leaves me with is 2 square roots of 3 plus another square root of 3. So I end up with 3 square roots of 3. That's my slope. Okay, that's the most work that we have to do there. From here, it's just about plugging it back in. So we get that y minus 1 equals the slope times x minus pi thirds. That's the equation of the tangent line. And last but not least, as I said, here is the proof. So I'm going to prove the derivative of sine of x is cosine of x. To do that, we need to recall a couple of our limits that I said that we had to know. The limit as x approaches 0 of sine of x over x is 1. And the limit as x approaches 0 of cosine of x minus 1 over x is 0. Okay, we need to know those in order to understand the algebra behind the derivative of sine of x. We also need to remember some of our trig properties, and we'll go through those as we go. Okay, so let's start. In order to do the derivative of sine of x, we are going to go back to our limit. So f prime of x, since sine of x is f of x, is the limit as h approaches 0 of sine of x plus h, that's f of x plus h, minus the original function, f of x, which is sine of x, all over h. Okay, so here's where you have to remember your trig properties. We have the property for the sum and difference of angles of sine of x. We're going to use the one for the sum, which says that the sine of x plus h is the same thing as the sine of x cosine of h plus cosine of x sine of h. And then, of course, we can't forget our sine of x from the end, all over h. I'm going to just reorder the numerator. So basically, I'm going to move the sine x cosine of cosine h to the second part, and I'm going to move the cosine x sine of h to the first part. So I'm just reordering it. I can do that because it's all addition on top. And as we know, addition is commutative, meaning it doesn't matter what order it is. As you can tell, I'm just talking while I do all the writing. Okay, so now what I'm going to do is I'm going to split my limit over top of the h's. So specifically, I'm going to split cosine of x sine of h over h, and then I'm going to split the whole rest of it over the h. Okay, we're allowed to do that because of the fact that we are just splitting something over a common denominator. Okay, so what I can do now is notice that each one of these things, the limit itself is as h approaches 0. So the cosine of x part has nothing to do with the limit. So technically, I can pull that cosine of x off to the side and just have sine of h over h. Still multiplied, but I can pull that off to the side. In the second one, what you should notice is I can factor out a sine of x on the numerator. So if I pull that sine of x off to the side, what that leaves me with is cosine of h minus 1 over h. And hopefully now you can see why we needed those properties or those limits that we had, because I'm taking the limit of the sine of x over x, or in this case h over h, as h approaches 0, just like the first one right here. And then in the second piece, I'm using this one. So in this piece right here, that limit right there is going to approach 1, which means that I have cosine of x times 1. And in this piece, that limit is going to approach 0, which gives me sine of x times 0. Of course, sine of x times 0 is 0. Cosine of x times 1 is cosine of x. So that is your derivative of sine of x. You could very easily do exactly the same general idea for cosine of x. I'm not going to do that one. I will leave that to you if you so wish, but that's plenty enough.